Hello, welcome on our online webinar live stream on YouTube controlled by automation. Today, I will introduce you to industrial communication protocols, especially to Modbus RTU. Okay, you can use those protocols in Industry 4.0, and the most popular protocols are OPC-UI, Modbus, MQTT, and Profinet. Just write in the chat which protocols do you use in your job, in your company. In the future, we will create an online course for industrial communication protocols, maybe next year. So please be patient. Our e-learning platform is growing. Let's go to my presentation. So the topic of my presentation is, of course, Modbus RTU and Modbus TCP. Try Modbus protocol in only 1 hour. And here we have the plan of our live stream. I will show you some tips how to start with Modbus RTU, Modbus TCP for Siemens TIA portal and Codesys. I will show you some diagnostic tools for Modbus RTU, which we use in our company to create for diagnostics. What is Waveshare Modbus RTU? This is a remote I/O hardware, and we use also that hardware in our project. This is a really cheap hardware for industry. And as a bonus, I will show you how to configure Wago PLC for Modbus. If you have questions, just write in the chat. I'm here to answer your questions. Hit the like button, subscribe, hit the notification bell to stay informed about our newest videos and live streams. Okay, let's go to introduction. I will show you a basic exercise which you can solve on your own. I will show you how to connect a Codesys device with the Finder Opta. You will use Modbus configurator in Codesys and Modbus TCP view. Okay, so here we have an example. Here we have the Wago controller. And let's say we would like to connect that via Modbus TCP IP with the Finder Opta PLC. What we need to do first? Firstly, we need to establish an IP address for each device and configure each device as a master in that configuration, or the slave. In that configuration, the Wago PLC will be master, and the Finder Opta will be slave. What does it mean that the Wago PLC is a master hardware? It means that the master create a query for the slave. For example, the master can write some registers to slave and read some registers. But what we need, the one tip for that is that the Wago is zero-based addressing. The addresses in Modbus start from address 0. And in the Finder Opta, we have a shift, and the address start from 1. So this device is zero-based addressing, and the Finder Opta is 1-based addressing device. So here we have a Codesys programming tool. We can program in the tool a lot of devices like Wago back off in the next year, you can program in this software, the Finder Opta. If you go to Codesys.com website, you will see how many devices you can program in that software. So you can program a lot of PLCs in Codesys. We use that software to program our projects and also simulate PLCs. You need only your computer to start with programming. You can just download Codesys for free and enable a PLC simulator. Also, you can create communication between your PC and external devices. You can use Modbus protocol. You can just install a PLC simulator. This is a real-time simulator, and you can create a program for a Modbus. On your computer, you can test your program and PLC simulation, and you can connect with, for example, a tool, Ocean Controls Modbus View TCP, and you can simulate Modbus device. Thanks to that, you can solve a lot of examples and understand how Modbus works. Here we have a sample network. As you can see here, we have a lot of Siemens devices, the most popular devices in industrial automation, especially in Europe. In USA, you have Allen Bradley, and probably in China and Japan, you have a lot of devices from Mitsubishi Electric. But here we have a sample network, and here we have a PC. We can install on that PC programming environment like TIA Portal or Codesys. Thanks to that software, you can write program and also write programs for communication. Just write on the chat which protocols you can use in such network to communicate: PLC, HMIs, gateways, inverters, and servo drives. To communicate such devices, you can use a lot of protocols. Yeah. So here you can use Profinet, EtherCAT, Modbus, like here. Also MQTT. On the chart I can see that Firas use Profibus. Blast Grinds use CAN for mobile machine automation, maybe. I have here in my office, I have even here I have the cable for CAN protocol for mobile machine automation. Okay, but it depends what you need. Profinet is good for communication with servo drives, for example, and HMIs for Siemens devices. EtherCAT is really quick protocol for servo drives. And Modbus is not good for servo drives. It's not so quick. And the communication is not secure. You can sniff all data from your network. So Modbus is really popular, is the most popular protocol in industrial automation industry, but it's pretty old. We have more protocols, modern protocols for Industry 4.0 like OPC-UA, MQTT. But if you want to be a professional, you should know how to use Modbus, because in a lot of cases, you use Modbus to communicate devices in our industry. A lot of industrial automation manufacturers like Beckhoff, Wago, Eaton, Wintec, Siemens, and Delta has a possibility to communicate via Modbus protocol. Like here on the photo, I have the Wintec HMI. Then I have a server drive, remote I/O from Wintec, and a network. Okay. If you want to implement Modbus, you should know that we have some differences between Modbus. The first one is Modbus RTU. It is based on RS-232 or RS-485. Okay, and this is serial transmission standard. The next one is Modbus ASCII. We use ASCII coding for this type of communication. And also we have Modbus TCP. Modbus TCP is based on Ethernet TCP/IP communication standard. Okay, it is equivalent of Modbus RTU, but uses the TCP protocol for communication on port 502. And we have advanced Modbus, which is Modbus Plus, but in a lot of cases, the most cases, we use Modbus RTU and Modbus TCP. Sometimes you can find Modbus ASCII in your future industrial automation applications. And here we have a sample network. Here we have a computer with TIA portal or Codesys. On the top, we can communicate via Modbus TCP in Ethernet network, Ethernet standard. But we can communicate with gateway using Modbus Plus, and we can communicate with inverter or servo drive using serial transmission and Modbus RTE. This is a sample application for Modbus. In Modbus, we distinguish two types of devices. The first one is a master. This device sending requests to the network. Okay, there can only be one master device in the network. And the second device is a device which receiving queries from the master. Here you have a sample network for Modbus RTU, which uses serial transmission RS-485. And here we have two cables for data cables, A- and B+, and ground. So we have three wires, okay? And this is a master device. Next, we have the slave number 1, slave number 2, slave number 3, and etc. So, Modbus master sends requests like read-write request, and after a short time, we have a response from slaves, slave number 1, 2, etc. The perfect combination What is the perfect combination for Modbus RTU? I have a few rules for you. The first rule is that for communication protocol ports, each device, master or slave, has a connection port with two terminals that are used to communicate with a given device via Modbus RTU. These terminals are typically marked A plus or B minus. This means all A terminals should be connected together and all B terminals should also be connected together. Maybe I will show that on real devices. Wait a minute. Thank you for your patience. Maybe I will change the view of my live stream. Okay. And maybe I will show that on this diagnostic device. This is a Wireshark. Okay. And look at that. Here I have okay. Here I have A plus and B minus terminals. I can sniff my network and I use this diagnostic device for that. Another device is such a remote I/O device from Vintech. But for that, I use Modbus TCP protocol. And the last one device, which I use to communicate in Modbus protocol, is Finder. Here I have A plus and A minus and B plus terminals for serial standard. Okay, so let's go to the next rule. The next rule, connection between devices. The easiest and the best way to connect devices in the Modbus RTU communication is to use daisy chain method. This is serial connection. No other methods of connecting devices are recommended because they may cause communication problems or damage to the entire system. And here we have example of daisy chain. Rule number 3, maximum cable length and number of slaves. If you go to documentation for Modbus, you will find information that the maximum communication cable length should not exceed 800 meters. It is recommended. And the maximum number of devices should be about 32 devices in the network. Rule number 4, termination. We need to terminate our network. In the end of the network, you need to add a termination resistance of 120 ohms. Rule number 5, grounding. We need to use grounding wire, especially when operating near high voltage sources such as photovoltaic panels, okay, or inverters. And rule number 6, cable types. For Modbus, we use twisted cable. And here I have an example of such cable, and it is Belden 3105A. This is a twisted pair cable. We have two data cables and everything of shield. Okay, this is an example of such a cable. Okay, I hope that you will use those rules in your projects. And remember, hit the like button down below the video if you want to learn more about automation and communication in industrial automation. Okay, let's go to the next slide. And here we have an example of an inverter. And such an inverter has a RJ45 connector, like here. And we use only 2 terminals for communication and earthing wire. We also use such terminals in some applications, some devices. Maybe, okay. Maybe I will show you next device. Wait a minute. Here I have such a HMI panel, and such a panel has a lot of terminals, and here I have also 2 terminals for communication via serial protocols like Modbus RTU. Here we have an example for termination. In the end of the Modbus network, we need to use a termination resistance. If you don't have that resistance embedded in the device, you need to add a physical resistor. But sometimes, like here in that inverter, we have parameters for that termination. We can add this termination via pins, okay? Like here we have pins and add such a termination. Or add specific parameters for termination resistor. Here we have an example of a solar farm. A device just is a master and take data from string inverter, central inverter, sensors, array box, and then we send those data from all devices to SCADA system or cloud service. But firstly, we need to use Modbus RTU or Modbus TCP protocol to gather all data. What about the frame? Here we have communication frame of for the Modbus, and this is RTU message frame for that. In that frame, we add slave address, which is 1 byte, a function code, which is also 1 byte, and data. In the end, we have a CRC check. Below, we have another frame for Modbus ASCII. We have a difference from that RTU message frame. What is the difference between a Modbus TCP and RTU? In Modbus TCP, we can say that Modbus TCP places a standard from Modbus RTU frame without a checksum and address field in a TCP frame. Moreover, at the beginning, it adds a 7-byte header called MBAP. So this is Modbus TCP frame. It is similar to Modbus RTU frame, but also we have MBAP header, which is 7 bytes. So the frame, it is different from the Modbus RTU, but also we add function code in the frame and data. If you use Modbus RTU or Modbus TCP, you have to know how to use function codes and how to map addresses in Modbus. If you want to use function codes, you need to use code of the function. Like here, we only read coils, we read holding registers, and we can also write registers and coils. Each of that function has its own function code. If you want to read holding registers, we use function number 3. Each device has a documentation, and you need to know how to use that documentation to find out how the mapping works. I have a question for you. Can floating point numbers be sent via Modbus? For example, you have a temperature sensor, and the variable is floating point, real type variable. Is it possible to send such a variable via Modbus? Just write on the chat. Okay, I have an answer. The registers do not provide for data representation for negative numbers for values over that value, and for fractional numbers, example 1 to 5 dot comma 138. So we can't send floating point numbers using Modbus, directly using Modbus, but we have some tricks how to do that. So the first case, for example, we would like to send a temperature from the sensor 42.35 Celsius degrees. We would like to send such a value of the temperature. So in the PLC, in the program, we can multiply this value by 100, and we store the value in the Modbus register. That value will be 4235, okay? And we can send this value to the SCADA system or PLC, and then we can divide this value by 100. In a lot of industrial applications, we use such a trick. The next trick is, let's say we would like to send 32-bit numbers, but using Modbus, we only can send 16-bit values. How to send 32-bit numbers? The solution is the master should read 2 Modbus registers. Okay? And thanks to that, we can transform 2 words of data into 32-bit number. So we have two tricks how to send floating point values through Modbus. Okay, and in the end, I have some tools for you, which we use in our PLC programming job. This device must be the last device. Yeah, the device with termination register should be the last device in the Modbus RTU network. What if we use more registers? Please, Blash, precise your question. Harley said that I think we can't send floating point numbers using Modbus. We can do it, as I showed before. So let's get back to my presentation. So the first tool is Codesys. And if you want to learn how Modbus work, how to write programs for communication protocols, you can just download Codesys from the website, from the Codesys website for free. You can start this software on your computer and you can start programming communication like Modbus. You can test on your computer. Yeah. It is free to download from codesys.com site. And you can start work on your Windows computer. The next tool is PLC-Sim Advanced, and this is Advanced PLC Simulator from Siemens. You can launch this simulator in TIA portal. Thanks to that, you can communicate your laptop as a real PLC using Modbus. The third tool is Modbus TCP View. This is a diagnostic tool. You can simulate each Modbus register of your device. It can work as a master or slave. And here we can just write values. Maybe I will show you this device. It is free in demo mode. And you can just write here values for Modbus registers. You can change for input registers, holding registers. You can configure that software. You can work as a master or slave. And the next tool is UI Expert, but this is a different tool for different protocol like OPC UI. But for Modbus, you can also use Wireshark. And look at that. You can sniff the data from the network, from Ethernet network, and you can see frames from Modbus TCP. Like here, you can read the frame data, but if you want to use it, firstly, you need to learn about the Modbus frame, the Modbus query, response, etc. Okay, and let's go to the practical slides. Here we have the program for Siemens PLC Modbus client. And we use such a block to configure Modbus TCP, and we use PLC Sim Advanced. This is a PLC simulator to communicate with different devices. Really nice tool is Node-RED. This is a web-based programming language. You use such blocks to configure your programs and also communication like Modbus. We use such a solution to communicate and simulate devices. The next block is Modbus client for Siemens. Here we have a documentation how to use interface for that block, how to configure such a block in a real world application. And here we have example of remote I/O, and this is Waveshare hardware for simple applications. We have 8 channels, which are remote output. Remote outputs, and we can control such a device using Modbus TCP or RTU, and this is a Modbus slave. If you want to communicate with such a device, you need to use master device. You can use Finder Opta or Siemens or Codesys, okay? This is only remote I/O using Modbus, but this is a slave device. In our course, we will simulate such a device in Node-RED, but we'll launch such a course next year. Here we have example of parameterization of the Siemens block. Here we have a documentation how to communicate a Siemens device with Node-RED and Waveshare. And here we have statuses of each output of our Modbus slave device. And write once again on the chat what protocols do you use in your job. I know that you use Profibus, CAN, but on our platform you will learn about Modbus and modern protocols we use in Industry 4.0. Okay, and here we have an example communication between Wago controller, which is programmed in Codesys, and we communicate such a device with Finder Opta PLC via Modbus. Here you can find a sample program written in Codesys for Modbus communication, okay, and sample visualization. Okay, and here, sorry. Okay, here we configure network interface for Ethernet adapter, IP address for Modbus. Okay, and here we configure Finder Opta Modbus TCP. In Codesys, for Vago, you have built-in configurator for Modbus TCP. You to just add an Ethernet adapter and configuration for Modbus or slave. Here we will write multiple registers. Maybe in the future webinars, I will show you how to configure that from scratch, or I will create a video for our channel. But it's really simple. First, you need to know you need to know about Modbus, and then you can write programs. Here we have the ready-made program for communication. We have both programming environments, Codesys and PLC IDE for Finder. Here we have another example, but in that case, we have a program for Modbus RTU communication, and we use a specific function block for Codesys. And here we have a simulation for Modbus slave. Oh, okay. Maybe I will show you the communication. And look at that. Here I communicate a Wago PLC using Modbus RTU with my Modbus slave. And we have here a query and a timer. Each second, we send a request using Modbus master to the network, to our slaves. And here we have, okay, and here we send data from Modbus slave to Modbus master, and we also send floating point number from potentiometer, okay? This is analog value. In Codesys library manager, you can find sample applications, and you can use that in your program. Here we have more devices, and we communicate Wago with Wintec remote IOs, which I have here on my table. And we use in our program a case structure for creating a query in Modbus TCP IP. Okay. And look at that. We have a sample application for communication PLCs with Wintec HMI. We use also Modbus here. We send floating point number, like here. We use a simple trick for sending floating point numbers. And here you have a view of a Node-RED map for simulating waveshare device. Okay, that's all for today. If you want to find out more, just go to our website, controlbyte.tech. If you go to controlbyte.tech, you can find free entry PLC course here and paid plan. We have a lot of courses on our platform. In the future, we will add industrial communication protocols course, but right now you can buy training for PLC programming for Siemens, industrial automation basics, and programming instructor for Codesys. We have also a blog. You can find here articles also about Profinet and Modbus. If you click on Modbus, maybe I will give you a link on the chat. You can find out more about Modbus TCP IP and how to use that in industry. So this is a bonus for today's presentation. In the future, we'll create more free videos for you and live streams, YouTube live streams for you. So hit the like button, subscribe to the channel, and hit the notification bell to stay informed about our newest videos. This is all for today. Thank you for coming. Go to contribite.tech and see you next time. Zizo, thank you very much. Thank you for attending the webinar. See you.